Hey gents, I hope you're well. Welcome to today's lesson. Today we are looking at the angles of all magnitude. Sounds strange, but basically what this is looking at is where we'll be asked to find the value of things like the exact value of things like sine 120 degrees as opposed from sine 60 degrees. Or you might even be asked to find the exact value of sine 210 degrees, or you might even be something like cosine of 300 degrees, right? And at the moment, you're probably looking at all these things going, how would you end up doing those? Because we only know how to do 60, 30, or 45 degrees. However, you might remember back to the lesson that we're looking at obtuse angles. And you know that we worked on the obtuse angles, and so we were able to figure out that sine 20, for example, was exactly the same as sine 60 because they were supplementary angles, add to 180 degrees, etc. We also worked out that we could find the value of, let's say, cos 120 because we knew that it had the same value as cos 60 degrees. Again, same thing, that supplementary angle. But we knew that the value would be negative because it's in that second quadrant. So we have spoken about this already. Now, if we go back to that unit circle all the way back quite a few lessons ago, and we look at our plane, this is what we spoke about. We let there be a point, I think we said point xy, okay? We then said, well, if it's point xy and we put a right angled triangle there with a theta in the middle of it, you know, we go across x, which means that's x. We go up y, so the vertical length is y. And then we came up with those values of sine theta. We came up with cos theta. We came up with tan theta. Okay, so sine theta, remember it's a unit circle, so the radius is 1. We got y over 1, which is just y. Cos theta was x over 1, which is x. And tan theta was simply y over x. Then we then said, and this is how we looked at it, we looked at the 180 degrees minus theta, okay, because that's the supplementary. It's 180 degrees, subtract the angle we've got. We did the same thing, except now we had negative x and positive y. We had 1 there. This is the point negative x comma y, and we did exactly the same setting. We said sine theta equaled y over 1, which is just y. We said that cos theta equals negative x over 1 is negative x, and we said that tan theta was y over negative x, which is negative y over x, and that's when we recognize, hey, sine theta and sine theta are the same in both quadrants. So that comes back to sine 120 and sine 60 having the exact same value. That's when we recognize that although cos theta was x, over here when it's obtuse, it's minus x. So they have the same number, but one's positive, one's negative. And that's where we saw this bit here. We saw we have one's a positive value and one's a negative value. And the same thing for tan. We saw it's positive in the first quadrant when it's acute, but when it's obtuse, it's negative. Now, that's what we've already done so far. If you can't remember that for a few lessons ago, maybe we'll go watch the videos again. But I then mentioned too that we can in fact go through and look at the next quadrant. Now, of course, this would be 180 degrees plus theta, if I put my theta inside there, okay? I'm going to say 180 degrees plus theta. So, of course, we look at acute angles, so maximum 90 degrees. So that would go all the way from 180 to about 270 degrees. So if you have an angle that's between those two amounts, for example, 210, this becomes useful. Now, look at the measurements. We've got minus x across in the horizontal. What would the vertical now be? Well, that would be negative y. So again, we could do the same three things. Sine theta equals, now in this instance, it'd be negative y, okay, over 1. Well, that's negative y. Cos theta would be negative x over 1, which is negative x. And what would tan theta be? Well, tan theta would be negative y over negative x. What happens when we got two negatives? Negative y over negative x, well, they become positive y over x. And again, what you're going to see is that for tan theta, it's going to be the same number as all the other three quadrants, except now in that third quadrant, your tan theta will be positive. So for example, if you chuck your calculator right now and said, what is tan 210? You're going to get a really long decimal, but you're going to notice that it is a positive decimal. And that's really cool because when you look at sine and cos, what happens with them? They're still the same number, okay, but now they're negative values. So we said that everything in the first quadrant, all acute, were positive values. In the second quadrant, only sine was positive, the other two were negative. Now in the third quadrant, only tan is positive, and the other two things are negative. What do you reckon is going to happen in the fourth quadrant just by looking at it? AST, you might think cos might be positive. So let's have a look now. We're going to do my triangle here. Now again, because my theta is inside there, we're going to go 360 degrees all the way around minus theta. So we call this 360 minus theta, that kind of quadrant. And let's do, so a positive x across, negative y down. Of course, it's a unit circle of 1. I'm going to put some right angles in there. Didn't do that, should have done that. Now, cos theta in the bottom triangle, adjacent over hypotenuse, x over 1. Look at that. It's positive. If I look at sine theta, okay, is opposite over hypotenuse, is negative y. Tan theta, okay, is positive, so negative y over x, which is negative y over x, and look at that. Cos is positive, everything else is negative, and so we say that is C. Now, people talk about the ASTC, or if we use some little mnemonics or stuff like that, we often say all stations to Central or Cronulla or Cabramatta or Caringbah, wherever you want to go, Como perhaps, okay, because the A is the first quadrant, the S, which is sine, is positive in the second quadrant, tan is positive in the third quadrant, and we have cosine is positive in the fourth quadrant. Now, how might this help us, okay? And it's still, these are the things that I want to be looking at as well, 180 minus theta, and this is where theta is. There's a lot going on, and I kind of get that, okay? I'll show you another video later on that might be more helpful, but bear with me. So let's say, for example, we want to find the exact value of sine, let's say, we'll say 150 degrees. Okay, we've already done this, okay? This was our supplementary angles, our obtuse angles. So this is in the second quadrant, right? We know it's in the second quadrant. It's in there because it's less than 180 degrees, but it's more than 90, so it's an obtuse angle. We know that this quadrant is called the 180 minus theta, which means this will have the same value as sine 30 degrees because 180 minus 30 is 150 degrees. We also know in that second quadrant that sine is positive. So it means that sine 150 will be exactly the same as sine 30. So I come back to this right angled triangle, 60, 30, 1, 2, root 3 for my exact values. Sine 30 is 1 over 2. Therefore, sine 150 degrees equals 1 over 2. I'll go to my calculator now. I'm going to type in sine 150 degrees. And I press answer, and there you go. Now, of course, your calculator could get you that answer on this particular case, but it might not later on. Okay, so let's apply this now to another question. Let's go tan 210 degrees. Let's have a look at this question. Now, of course, if I get my calculator out and I type in tan 210, and I press equals, we get 0.57735, right? It's not an exact number, it's rounded. We can't do that. I do know it's positive. Calculator says that part of it. However, let's think about this first of all. We know that it sits in that third quadrant, right? 180 plus something makes 210. So we call this before the 180 plus theta because it's the angle inside it that I'm looking at. So 180 plus something makes 210. Well, that's 180 plus 30, right? So some people might say straight away, well, that equals tan 30 degrees. They might say that equals tan 180 plus 30 degrees because that's the same as 210. Either way, I'm looking at this tan 30. Now, the first thing I know that's what the value is going to look like. It's going to be the same number as that. Is it going to be positive or negative in the third quadrant? Well, ASTC ASTC, tan is positive in that third quadrant, so I know that it's simply going to be the same as tan 30. I come back up here to my triangle and say, well, tan 30 is 1 over root 3, and we know it's positive. Bang, got my answer. Now, I guarantee if you go 1 divided by root 3, you get that answer that you got right at the beginning of positive 0.577. So I'm hoping you can start to see the advantages of knowing this unit circle. What if I said sine 300 degrees equals? Now, again, you might be lucky. You might type in sine 300 on your calculator, and it says negative 0.866. Well, at least you know it's negative. Okay, your calculator told you that much, but we can work it out either way. So let's look at my unit circle. That fourth quadrant, we know that's where my angle sits inside there. We're going at around 360 degrees, and we're minusing a number. We call it the 360 minus theta quadrant. Well, what do you minus to get back to 300 degrees? Well, you minus 360 minus 60, right? Or otherwise, we know that the number will be the same as sine 60, okay? We know it has the same number. However, is it positive or negative? Well, we looked at the calculator, we know it's negative, but of course, ASTC, in that fourth quadrant, only cosine is positive, which means sine is actually negative. Now, I go to my my exact value triangle, and I look up here and I look at the sine 60. Well, that's root 3 on 2, and I know it's a negative. Exact values, done. So what we can see by using these four quadrants, there are two things that we need to figure out. First of all, what acute angle is it the same as? Because that's the value I need to get. Okay, is it the same as sine 60, sine 30, sine 45? I apologize for my dog there. What's the actual number? Is it root 3 on 2? Is it 1 over 2? Is it going to be, whatever it might be? You might be lucky because you might get an exact value off your calculator in the first instance, for example, half or positive 1 when it's tan 45. That's the first thing. What does the number look like? And the second thing is it positive or negative? Now, although, yes, your calculator will help you in this instance, because you can type it in and see if it's positive or negative, later on you won't be able to. The last thing I'm going to look at, because I know we're at 12 minutes, it's a little bit different, it's high-level stuff. Later on, you'll be given things like this. You'll be told that sine theta equals root 3 on 2. And you'll be asked to find out what the angle is. Now, you might go, oh, that's nice and easy because I can simply do shift sine root 3 on 2 and get an answer. But there's a distinct problem because sine is positive. And sine can be positive in more than one quadrant. If I, in fact, do shift sine and then do my root 3 over 2, and close my brackets. Okay, I didn't do shift sine root 3 on 2, and you're most welcome to do this. Okay, you might find that it doesn't give you what you need. It gives you 60 degrees. Problem is, it can be 60 or it could be 120 degrees. Now, that's quite nice because you go, okay, I can figure out, as long as I know which quadrant it's going to be in, I know what the acute angle is, it's going to work out nicely. The problem is later on, when you do things with like cosine and tan, it doesn't give you the right answer. It really muddles it up. So later on, and again, this is a little bit later on, you might be told we'll do tan theta equals root 3 on 2. Root 3 on 1. Actually, 1 on root 3. We'll do equals negative 1 on root 3. Okay, you might be given this question, right? The positives are okay. Negatives are really quite challenging to do on the calculator. So I get this question later on, and the first thing I'm thinking about is this, right? Which quadrant might this sit in? Tan's negative, right? Where is tan negative? Well, ASTC. I know that sine is positive in the second quadrant, which means tan is negative in the second quadrant. I know that tan is also negative in the fourth quadrant because it's going to be positive in first and third. So I know that it sits in either the 180 minus theta quadrant, or it sits in the 360 minus theta quadrant up there. So what I need to do first of all is to figure out what theta is. And if you go ahead and press Shift 10, -1 on root 3, most likely your calculator isn't going to give you a very nice value. Funny enough. So I then go and look at my triangle, and this is my 60, 30, 1, 2, root 3 triangle. And I can look at this and say, okay, well, where is opposite over adjacent, which is tan, 1 over root 3, this part of it? Well, for 30 degrees, we can see opposite is 1 and adjacent is root 3, which means theta initially looks to be 30 degrees. However, we know that can't be in the first quadrant because it tends not positive, which means it has to be 180 minus 30, which equals 150 degrees, or it's going to be 360 minus 30, which equals 330 degrees, which means that for this question, okay, of tan theta equals -1 on root 3, they're my two possible answers that I could have had. So you can start to see where this gets really tricky down the track. Now, because you're accelerated, these are things that you should be working towards as well, and I'll try and include some work on this down the track. It's quite challenging, but it's also pretty fun, okay? So the two biggest things for me is know your exact value triangles, okay, your 1, 2, root 3 with your 60, 30 triangle. Know your isosceles right angle, 1, 1, root 2 with the 45, because that will help you get the exact value part of it, okay, or work out which angle you need. And then you want to look at your unit circle, ASTC, all stations 2, wherever you want to have it, okay, Keringai. No, Kringai's with a K, isn't it? Okay, Cronulla I like. And then you know where it's going to be positive or negative depending on which quadrant you need to look at, okay? It's tough, it's tricky, but that's why we're in these classes, because we want to learn more, we want to push ourselves and challenge ourselves. Have a wonderful day, gents. Hope you're well, and I'll see you next time.